Hello students, how you all? Hope all are doing good, right? So welcome back to daily practice session. So this is how we can represent a uniform electric field. Okay, so along this particular direction we have some electric field, uniform electric field. Let us take one positive charge here. Okay, a single charge that is at rest. Okay, that charge is in equilibrium. What do you mean by equilibrium? When net force acting on any object is zero, then we can say that is in equilibrium, translational equilibrium, right? So here also this charge is at rest. That means the net force acting on this charge must be equal to zero. So this is electric field. Electric field is, if field's direction is from bottom to top or it is in upward direction, right? Therefore this positive charge, if you take that as Q, that will experience some force in upward direction, correct? No, that is electric force is experienced by this charge in upward direction because force will be in the direction of field. Electric force is in the direction of field. So what is the expression for that force? F can be written as Q into E. Yes, F equal to Q into E. That is how we can represent electric force. Okay, that is the one force acting on this. Now, is there any other forces acting on this? Yes, one more force is acting. As I said, this is at rest. Now, that charge that has some mass, right? That has some mass. So, due to that mass, there will be some weight or some gravitational force is acting on that charge. That means the weight of this charge will act in downward direction. Okay, so these are the two forces acting on that particular charge. Now this charge is at rest means, as I said, the net force must be equal to zero. When you get net force as zero, when these two forces are equal and opposite, then we can say that the net force on that charge is zero. That means at equilibrium, net force is zero. That means this QE must be equal to mg. Okay, so this is the condition for equilibrium of this charge. Okay, so this is very important concept. If you go through or if you refer previous year question papers of NEET, JEE or KCET question papers, you will get some questions based on this concept. Okay, so if the charge is at rest in an electric field, then we can say that this that net force on that charge is zero. That is QE must be equal to mg. So from this you can calculate the required data. For example, if they ask you to calculate Q, you can rearrange for Q, or if they ask you to calculate mass, you can rearrange for mass, right? So this is the concept of suspension of charge. You can say that charge is suspended or that charge is floating, okay, in an electric field. Then you can use this concept. Similarly, one more case let us take. Okay, so here I have one more electric field, but this electric field is in horizontal direction. This electric field is in horizontal direction, right? So now if you place a charge here, a positive charge is kept in this electric field. Now what happens? As I said, the force will be in the direction of, or force is always in the direction of electric field. Therefore here the electrostatic force will be in this direction, QE, correct? No, the electrostatic force is acting in the direction, electrostatic force is acting in the direction of field. So we can take force along this direction. So now due to this force, this charge gets accelerated in the direction of field. Okay, due to this force, charge gets accelerated in the direction of field. So you can write the value of acceleration now, or you can find out the value of acceleration. Now what is the net force acting on this? That is QE. So in general we have force F is nothing but m into A, but here we got F equal to Q into E. So using these two, we can write m into A must be equal to Q into E. Correct, no? m into a, that must be equal to q into a. So from this you can rearrange for a, no? You can rearrange for acceleration of that particular charge in an electric field. So that is nothing but a equal to qe divided by m. Okay, so that charge gets accelerated in the direction of field and its value is given by qe divided by m. So what about initial condition? Before applying that field, if you just hold that charge, that means if you consider v naught equal to 0, if charge is initially at rest and if it is released, okay, initially it is at rest and then if you release it, then that will move with certain acceleration. That acceleration is given by this expression. So this is initial velocity. Initial velocity is 0. Now if you want to get the value of velocity or speed after certain time t or at an instant t, okay, if you want to get the value of final velocity at a time t, then how you can calculate? You have a kinematic equation v equal to v naught plus at, right? If you know the value of t and if you know acceleration, you can calculate v. Why? This v naught is 0. So from that we can rearrange for final velocity. Final velocity is nothing but 0 plus at. What is a? A is qe divided by m into t. That means velocity, final velocity is given by qet divided by m. Yes. So this is the expression for final velocity when time is given. When time t value you know, electric field value you know, and charge and mass, all these values are known, then you can calculate final velocity. Similarly, if you want to get the value of some displacement, okay, within that time t, how much distance is covered by that charge that moves in the direction of field, right? That moves in the direction of field. Therefore you can get the value of displacement. So s is equal to v naught t plus half a t square, correct? So now as I said, v naught is 0, so this term becomes 0, so we can write s, that is equal to half into a, that is qe by m into t square, right? So this is how we can calculate the distance traveled or displacement within that time t. Okay. Similarly, as you know velocity, you can calculate kinetic energy, right? Kinetic energy k, that is half m into v square. Half into m into v square. So what is the value of v? Let us see here, right? So what is the value? Value of v is qet divided by m. Qet divided by m. Just substitute that value. So what do you get? Half into m into qet divided by m whole square, right? So from this 1m can be cancelled, 1m can be cancelled, so final expression for kinetic energy. So kinetic energy, that is equal to half m, or m can be cancelled, and this q becomes q square e square t square divided by 2m, correct? No, where q charge, e electric field, t time, and m is mass. So these concepts are very, very important. Okay, expression for acceleration, expression for velocity, expression for displacement, and expression for kinetic energy. Hope you got it. Okay, just go through these concepts once again. Okay, thank you.